left off with the last two examples where we're solving the equations. Okay, equations involving rational functions. The first equation that we're going to solve, x minus x plus 2 over x minus 1 equals 3x minus 2 over x minus 1. The very first step in solving one of these rational equations is you have to find your least common denominator. So I need you to look at the denominators. And what's one of the denominators you see? X minus 1. What else do you see in the denominator? A 1. Okay? So that means our least common denominator is going to be x minus 1. That's it. Now what we're going to do with our least common denominator is we're going to take it and we're going to multiply it times each term in the equation. So this first x gets multiplied times the LCD, x minus 1. Then I bring down the minus, and I bring down this fraction, x plus 2, divided by x minus 1. But that fraction also gets multiplied times the least common denominator of x minus 1. Okay, so I multiply the numerator by x minus 1. Bring down the equals. Then I take this last fraction, 3x minus 2 over x minus 1, and I multiply it by the least common denominator of x minus 1. Okay, so do you see what we've done? We've taken the least common denominator and we multiplied it times the first term, we multiplied it times the second term, and we multiplied it times the third term. Now we're going to simplify where we can. Okay? In this second term, when I multiply that LCD times the existing fraction, what can I do with those x minus 1s? Cancel them, because I have a common factor on top and bottom. In the last fraction, I can also cancel the least common denominator of x minus 1 on top and bottom. So now we see what we're left with. I have x times x minus 1. So I'm going to distribute that x throughout the parentheses. So that gives me x squared times x times negative 1 is negative 1x. Minus x plus 2. So I'm going to write it as minus x plus 2 because that minus sign needs to be distributed throughout the parentheses. So I bring down the x squared minus x, minus x, because I'm distributing the minus sign, minus 2. That is a very important step. If you don't get that negative sign distributed throughout, then the entire thing is going to be wrong. Okay? Equals, now I have left 3x minus 2. So I bring that down, equals 3x minus 2. Now we need to combine like terms. So looking on the left-hand side, I can combine negative x minus x. So that's x squared minus 2x minus 2 equals 3x minus 2. Move everything to one side. So I'm going to subtract 3x from both sides, and I'm going to add 2 to both sides. So I have x squared, negative 2x minus 3x is minus 5x. Negative 2 plus 2 cancels into 0, equals 3x minus 3x cancels, negative 2 plus 2 cancels, so we're left with what? 0. So I have x squared minus 5x equals 0. Solving that, I can factor out an x, so I factor it out, and I'm left with x minus 5 equals 0. Let me bring it up here. Set each factor now equal to 0, so x equals 0 and x minus 5 equals 0. So our solutions we get x equals 0 and x equals 5. Now notice what else it says in the directions. What did it say? Check for extraneous solutions. What does that mean? check for a solution that may not work. I have two solutions, so separately I need to plug them into the equation to see if they're going to work. So let's start with checking x equals 0. 0 minus 0 plus 2 divided by 0 minus 1 equals 3 times 0 minus 2 divided by 0 minus 1. So 0 is just 0 minus 2 over negative 1. What's that going to come out to be? A negative 2 divided by negative 1 is just 2, because the negatives cancel out. Then I have 3 times 0 is 0 minus 2 is negative 2 over negative 1, which is 2. Do they equal? Yes. Now we need to check x equals 5. So 5 minus 5 plus 2 over 5 minus 1 equals 3 times 5 minus 2 over 5 minus 1. So 5 minus 5 plus 2 is 7, 5 minus 1 is 4, equals 3 times 5 is 15 minus 2 over 5 minus 1 is 4. If I have to do 5 minus 7/4, what can I change 5 into? So, and then 5 over 1 becomes what to get that denominator of 4? 20. So 20 over 4 minus 7 over 4 equals 15 minus 2 is 13 over 4. What is 20 over 4 minus 7 over 4? 13 over 4. So are those equal? Yes. So both solutions worked. So I go back up and I box both of them. Okay. Questions? Okay. Then let's look at the second one. 4x divided by x plus 4 plus 3 divided by x minus 1 equals 15 divided by x squared plus 3x minus 4. First thing we have to do is we have to take that last denominator and factor it. So when I factor that denominator, what do I get? X minus 1, x plus 4. Good. So we have to determine the least common denominator. What's one piece that has to be in the least common denominator? X minus 1. Is there another piece that has to be in our least common denominator? X plus 4. Is there any other piece that needs to be in that least common denominator? No. So now we multiply the least common denominator times every fraction. So we have 4x times the least common denominator, x minus 1 times x plus 4, and that's over x plus 4, plus the next fraction, 3 times the LCD, x minus 1 times x plus 4, that's divided by the denominator x minus 1, equals the last fraction, 15 times the LCD, divided by its denominator of x minus 1 times x plus 4. Now we go through each and cancel what we can. So in the first fraction, we can cancel out x plus 4. In the second fraction, we can cancel out x minus 1. In the last fraction, we can cancel out the x minus 1s and the x plus 4s. Now let's go back and simplify. The 4x gets distributed throughout the parentheses. The 3 will get distributed throughout the parentheses. So the 4x times x is 4x squared. 4x times negative 1 minus 4x. Bring down the plus sign. Now I have to distribute the 3 to the x plus 4. So 3 times x, 3x, 3 times 4, plus 12. And that equals, the only thing we're left with over there is 15. Okay, now we simplify. 4x squared Negative 4x plus 3x is minus x. If I subtract the 15 over, then 12 minus 15 gives me negative 3 equals 0. Now we need to see if we can factor that. Let's try 4x and x. What are the factors of 3? 3 and 1. So let's think about, could I put a 1 there and a 3 there? Will that work? No, because then that would be 1x in the inner and a 12x in the outer. Will that give me a negative 1 in the middle? No. So let's try switching those. Can I do a 3 here and a 1 here? That'll give me a 3x in the middle and what on the outer? 4x. Which one will give me a negative 1x in the middle? Negative 4x. So 4x times 1, that needs to be a negative 1. And then the 3x is going to be positive. Take each factor, set it equal to 0. So we get x equals negative 3/4 and x equals 1. Okay. Checking. Checking. Look at the x equals 1. What's going to happen when you plug in x equals 1? Oh, look at that. 1 minus 1 gives me 0 in that denominator. So is x equal 1 going to work? No, that's our extraneous solution. Okay, so now let's try the negative 3/4. Checking negative 3/4. We're going to have 4 times negative 3/4 divided by negative 3/4 plus 4 plus 3 divided by negative 3/4 minus 1 equals 15 over negative 3/4 squared plus 3 times negative 3/4 minus 4. All right, 4 times negative 3/4, that gives us negative 3 divided by negative 3/4 plus 4. So the 4 is going to change to 16/4. 16/4 minus 3/4 is 13/4 plus 3 over negative 3/4 minus 1. So the 1 changes to minus 4 over 4. So negative 3/4 minus 4 over 4 is negative 7 over 4. Okay, we're going to get there. 15 over negative 3/4 squared becomes positive. 3 squared is 9. 4 squared is 16. Plus 3 times 3/4 is 9/4 minus 4. Okay, this guy, negative 3 divided by 13/4 means we multiply by the reciprocal. So times 4 over 13. So that is negative 12/13. This guy is 3 times negative 4/7. So that's negative 12 over 7. So plus equals 15 over, can I get common denominators there? 9/16 plus 9 over 4. So I need it to become 16. So what's 9 times 4? So that's 36 over 16 minus, and that 4 becomes, let's see, what's 4 times 16? 64 over 16. Okay, so that's 15 over. 9 plus 36, 45. 45 minus 64 is that negative 19? Negative 19 over 16. So that's 15 times negative 16 over 19. Okay, now those numbers are just getting really big. Okay, I'm just going to tell you, that one works. That one works. I am not going to have a solution on there that will be difficult, like a fraction, to go back and plug in and check. Okay, that's not going to happen on the quiz. I didn't know it was going to get that complicated. I thought it was going to be, oh, we just plug it in and hey, yay, it works out. Okay, so if there's something super complicated like that, you can use a calculator. Okay, deal? Deal. Okay. The main thing you're checking when you're checking for solutions is something that when you plug it into the denominator, you can quickly see, hey, that's not going to work. Okay? I can see x equals 1. That is not going to work. So I'm looking to make sure that's the one you're crossing out. Okay? All right, so we're just stopping it there. Any questions on solving equations?